There we go. All right, so what is our reasoning? Why is 5/8? Oh, Freya. Oof, you're tempting me. You're tempting me, but I can't. Even though it'd be cute. Gray is like my cat Samson that I had. So talk to Freya if you need a kitty. Super cute. Kitties are fun. They're good online school companions. So I'm trying to force mine to stay on my lap and snuggle when I'm on the computer. We're getting there. She's getting close. Yes. Oh, you're licking me. Oh, you're so nice. All right. So what is our reasoning, guys? Why do you think 5/8 is bigger than 12/17? What did you do? And remember, there's like multiple ways to think this through. Like, even if you're like, well, I took a guess and I reasoned it this way, I want to know all of it. Because this is an area of math that, it's not my strong point. I like to calculate and be precise, but some people just have that reasoning ability. They're really good at it. What do you guys think? What about you, Marina? Even if you did calculate it, that's okay, because that's the way I'll show you guys. Do, 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 do. And I know we're using chat kind of exclusively, but remember, you don't have to. It's okay to unmute yourself and talk if that's easier. Totally fine. And if I'm blabbing and you interject, I will stop talking. I like to talk, so yeah. What do you think, Miss Marina? Freya, what do you guys think? If you don't know, that's okay too. Just type something. No, I'm just kidding. Just kidding. Oh, that's okay. So what made you agree with Marina? Like, did it just seem right? Okay, a guess. Seems like the right answer. Sure, and that's okay to say. That's fine. That's a part with, just hinting at it. There's a lot of ways that you can think it through. What I would do, I'm going to share what I would do. So I would take a calculator because my brain is very direct there. And I would take the top divided by the bottom to get the decimal. So I'm going to go 5 divided by 8. And that gives me a decimal of 0.625. Because for me, it's easier to tell what decimals are bigger. And then I'm going to do the same to the other one. 12 divided by 17. Oh, check it out, guys. And that actually gives me 0.7058. Blah. So which one's bigger? Yeah, Emma. Yep. Emma, you got it. So Emma, did you calculate it like I just did?
I used the least common denominator.
Oh, very cool. So you got them both to the same denominator?
Yeah.
Very cool. So what is the same denominator here?
130.
130. And did you get that by multiplying them?
Yeah, I just kind of used a calculator and tried.
Cool. Very cool. Yeah, 130. If you ever can't think of a common denominator, you can just multiply the 8 and the 17. Oh, is it 136? Let's see. 17 times 8. Oh yeah, that's 136. But either way, common denominator. And then whatever you do to this one, 17, we multiplied 17 by 8 to get 136. So we got to do the same to the top. We got to go 12 times 8. And that gives us 96. And then for this one, we multiplied 8 by 17 to get 136. So we got to do the same to the top. 5 times 17. 85. Emma, excellent suggestion. So that, even if you make an error and you do like the wrong common denominator, even if it's just a little bit off, you still are able to tell that. And that's the great thing about these questions, because they're not asking for the common denominator. They just want to know which one's bigger. So even if you're a little off, your method could still get you the right answer. That's why these questions are awesome. Very cool. Did anybody else like draw pictures or anything? If you hear, I don't know. Are they the iPhone earbuds? If they're like the Apple earbuds, they probably have the microphone on them. But if they're just regular earbuds, they might not have a microphone. And then if your computer has a microphone, you would probably have to unplug your earbuds for it to pick it up, I think. Yeah, it's certainly worth playing around with, but there are earbuds out there that have microphones. Okay, are they like the ones that come with an iPhone, the white ones, or are they different earbuds? Yeah, the Apple earbuds work with the mic. I know that because I had a student who did that. Well, what color are they, Freya? Hmm. So probably not the Apple ones, unless they're new or something and I don't know about it. But I'm not sure. Yeah, it would might maybe you could take a picture and send it to me. Okay. So I'm guessing they probably don't have a mic on them, but I'm not 100% sure. The Apple ones do because they have like a little thing on the cord. They have like a little box thing. So if you don't have anything like on the cord up by the buds, then there's probably not a mic on there. So if you wanted to use your, oh, that's a great idea too, Marina. You could Google the brand name in the description. Yeah, like to turn it up. Sometimes they put a mic in there. I'm not sure, but I would do what Marina said. I would type it into Google. That's a good idea. That's a great idea. Good questions. So, okay, we are going to talk exponents today. I love exponents. Oh my gosh, you're not weird. I'm weird. My husband jokes about my social awkwardness all the time. So, yeah, you should see me out in stores with my crazy children. Oh boy. I will never forget the day we were in Pick and Save, and apparently Logan said something to Elizabeth that made her mad. So she took a loaf of bread and smacked him with it so hard that the loaf of bread busted open. Yeah, those are my children. And I'm not gonna lie, I thought it was pretty funny because he did deserve it. He can be kind of, she's only 5, so I tell ya. No, it was funny. It was pretty good. Okay, so don't forget maps testing next week and conferences on Thursday. So come visit. Yay. Okay, so today we are going to talk about exponents. Lots of stuff with exponents. first question we have up there, and if I were you, I would definitely have a notebook ready. I will tell you what you need to write down, but it'll be really helpful to you to have these rules written down somewhere. The rules of the exponents. Okay, so what's the difference between simplify and evaluate? What do you guys think? If you see the word simplify, what do you guys think? Like, I might give you the problem of, for simplify, I would say 2x plus 3x. That's one thing I would say. And I would say simplify that. What would that be if you simplify that? 2x's plus 3x's. How many x's total? Yeah, I think you're thinking of the actual variable itself. But when we simplify, they both have an x, so we can just add those puppies together. 2x's plus 3x's. It's like 2 xylophones plus 3 xylophones. We are left with 5 xylophones. Very good. So that is the meaning of simplify. You don't really get an answer. You just get a more simple version of what you had before. So when you simplify, you may not get a numerical answer. And that traditionally weirds out algebra students a lot because you always think it's math, it's a number. But that might not be the case. When you evaluate, that's where you're going to get a numerical answer. So that brings me down to this guy down here. We got a little, and I got my chat menu up. You guys cannot see my chat menu, correct? I just want to make sure it's not blocking stuff. Okay, cool. Okay, so for exponents, okay, the cool thing I found was Ben. Remember Ben. Remember, that's my brother's name, so don't forget about Ben. But B stands for your base. E stands for exponent. And N stands for number. Okay, and an exponent tells you how many times you're multiplying the base. So if we have 3 to the 4th, okay, my base is 3, my exponent is 4, that means I'm taking 3 and multiplying it 4 times to get 81. So in this one here, in this evaluate 8 squared, how many times am I going to multiply that 8? 2. Yeah, I'm going to go 8 squared is the same as 8 times 8, which is 64. Yeah, that's one of our perfect squares. 64. So when you simplify, you kind of condense it into a smaller version. It might not always be a number, might be a variable. When you evaluate, that's when you get a number. And don't forget about Ben. This is a good, so for what you write down, I would write down Ben right here. I would write down this stuff and this example here. That's what I would do. Give me a minute. Oh my gosh, I can't stare at my cat. She's making me sleepy. I was watching The Office, and Angela made brownies for everybody, so now I can't stop thinking about brownies. Should have got some. If only the lady bought more plates. Right? Oh, doesn't that sound good? Cat, make me brownies. Yeah, no, that's not going to happen. All right, is anybody writing stuff down still? Or can I switch? Can I switch it? All right, I'm going to switch unless somebody tells me, no, don't switch. I'm writing notes. Remember, I will post it right on Moodle right after the live session, so you can always go on there if you miss some notes. Okay. So there's a lot going on here, I know, but all I want you to do is think about how you would write each expression in exponential form. So I'll pick one of the crazier looking ones. So I'm going to pick this 9p whatever. So there's a 9. There's only one 9. So I'm going to write that 9 down. And there's two p plus 1s in parentheses being multiplied together. So since there's two of them and they're using multiplication, instead of p plus 1 times p plus 1, I can change it to p plus 1 squared because it's being multiplied twice. Okay, so go ahead and let's have who would be willing, just so it's not too crazy, I'd like to pick different people here. But if you guys pull up your participant list, there's actually a way you can raise your hand on there. There should be. Yeah, I can't bring it up because I am teaching. But oh, cool. 3 participants. Yay. It's gosh. Okay, Emma, I see your hand on the camera list. That's cool.
Sorry, I didn't quite catch that.
Oh my gosh, my phone thought I was talking about Siri. That's crazy. It's never happened. Okay. Emma, could you please write what you think A would look like in the exponential form? So what our base would be, and then raise it to that exponent. Yeah, very good. 6 to the third. Right. Oops. 6 is our base, and it's being multiplied 3 times. So the base is what is getting multiplied. What about B? Who can do B? B, 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 B. Addie, what do you think B would be? And you can write it or type it in chat. Your choice. Dealer's choice there. Perfect. Very good. One thing we want to add, just because it's a negative, yep, you got it. We want to keep those parentheses around it, just because we want the whole -3 to be raised to the 4th power. Good. What about C? Who could do C? C, C, C. C, señorita. Evan, what do you think, Evan? Looked good so far. You were probably moving it, hey? Yeah. Nice. Very nice. Very good. -4n is the base because that is what is being multiplied. And there are 5 of them. Very good. What about D? D, 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 D. D. Remember, for D, when I did E, it's very similar to E. Whatever was only being multiplied once, I just kind of left there. Emma, you got this one? D, 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 D. These are good ones. I was excited to find this online. I was like, yes. It was a Google image picture I stole. I love Google images. Oh, pardon me. So D. D, 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 D. And here's a trick question. If you have two numbers in there, remember, even if they're different bases, if it's just a number, you can multiply them together. Nice. Very nice. Very nice. I would probably change the 4 times 3 to a 12 just because they're two numbers. But you're not wrong. That's perfection. Perfektenschlag, which is what Dwight would say. And then usually we want to go in order, although here it could be argued that you could put a y first, but usually we go in alphabetical order. So x squared, and I think there's actually 3 y's. So y to the third. Perfektenschlag. Thank you, Emma. What about F? What do you guys think? F as in feather or Freya. Just kidding, you don't have to if you don't want to. What do you think about F? What do you think? Emma, what do you think, Emma? I'm watching the hand raisers. I haven't gotten my popsicle sticks yet, but I will. I like that. I think it's important that everybody has a chance to, answer and ooh, the sirens are going off crazy. I think it's just the noon siren. Yep, it's noon. What do you think, Emma? Okay, Emma says negative 5x to the, look at that, Perfektenschlag. It's my new word. It's not my word, it's Dwight's word. Excellent. And what about G? What about G? What do you guys think? Remember, the base is just what's being multiplied. Addy, Perfektenschlag. Excellent. Very good. So we got that. Last little bonus question. What if it's fractions? What about that? Does that really change anything? What do you guys think? You can raise your hand for this one as well. So what if I'm going 1/2 times 1/2 times 1/2? Emma, what do you think? It's a weird font there. That looks so weird. I kind of like it though. Yeah, perfect. Very good. I love how you did that. You still want to put parentheses around your fraction. And then, yeah, you raise it to the third power. And just so you guys know, on the computer, the way you show that is with the little caret thing. It's on the 6. So you would hit shift and the 6, and it's the little caret thing. That means raising to a power. So yeah, very good. Good, good. Anybody still writing down, or can I switch it? Switch. What do you guys think? Nathan, Jaden, Nadia, Marina. I know Marina, you already handed stuff in. Cade. And if Evan, what do you guys think? Switch it? Okay. And if you have already done this, it's, up to you. If you get to a slide, you were like, whoa, that was confusing. Maybe you'd want to take notes there. But if you know it, you know it. That's good. Okay, so we see the lovely evaluate question here. So we just want to say what the answer is. And let's say you're stuck. Let's say you're like, oh my gosh, I have no idea how to do this. Coolest thing about online school, oops, not that, is the vast amount of resources at your fingertips. So if I were to exit out of here, let's say you were like, I'm just kind of stuck. I don't know. I'm going to recommend a website. It's called www.desmos.com. You could do the graphing one, but you don't need it. /scientific. This is a great little calculator. I'm going to put the link in chat. So we can type stuff in exactly how it's shown on the screen. Our first question is -7 raised to the second power. So I can type it in just like that. -7, and then I'm going to raise it to the second power. And boop, answer shows up there, 49. So -7 to the, sorry, trying to move stuff around, second power is the same as -7 times -7, which is 49. So did anybody click on that link and try Desmos? Oh, I sent that link privately to Freya. I'm sorry. Let's do everyone. Okay. There you go. I put the link in there for everyone. My bad. Sorry, guys. So go ahead and click on it, give it a try, and let's have you guys enter 7 to the 0 power. What do you get? What do you guys think? What is 7 to the 0 power? And you can check that on Desmos. And that relates to an interesting little property we're going to go through today. 7 to the 0. One, right. Very good. 1. So, yeah, anything raised to the 0 power is going to be 1. Anything. So even if it says 5x to the 0 power, what do you guys think 5x to the 0 power is? 1. Yep, you got it. Anything to the 0 power is 1. Anything. What about down here? We have 6 to the 0 power plus 8 to the 0 power plus y to the, so we're going to do some order of operations here. We got to take care of these exponents first. So what is 6 to the 0 power?
1.
1. Very good. What about 8 to the 0 power? 1. What about y to the 0 power? You'd think so. I'm really glad you said that. It's actually going to be 1. I'm really glad you said that, Evan, because everybody does that. Y to the first power is actually y. Y to the 0 power is 1. No matter what it is, anything to the 0 power is 1. You could even take like smiley face to the 0 power and you get 1. Anything to the 0 power is 1. So then we're going to add up these 3 ones and we get a total answer of 3 for that one. Right? Smiley face wins. Yeah. Okay. What about this one? This 4 squared. What is this the same as? What are we multiplying in that one? What do you guys think? In this next example here, what are we multiplying? 4 squared.
16.
It would be 16. Yeah, we are multiplying 4 twice, 2 times. So we get 16. Now this next one you could put in Desmos. You totally could. The rule is that this is the same as taking negative 1/3 and multiplying it 3 times. So we're going negative 1/3, negative 1/3, negative 1/3. And see how that negative is out front? I always stick it in the numerator. Way easier to deal with. If you have a negative out front, it just means one part of that fraction is negative, and I would just put it in the numerator. Okay, so then we multiply straight across. Negative 1 times negative 1 times negative 1. What would that be? Negative 1 times negative 1 times another negative 1.
Negative 1/27.
Right, very good. She's on fire. I love it. Negative 1/27. That's what you get when you multiply everything in the numerator. You get negative 1. And everything in the denominator, you get 27. Cool. Questions on that? Any questions? Any questions? No questions. Going to switch. If I need to go back, let me know. Okay. So now we're getting into the rules of exponents. And these are really important because they're going to come up, oh my gosh, in a lot of different areas. In Algebra 2 and geometry, like these are some pretty big rules here. So first rule is when you are multiplying exponents that have the same base, you add the exponents. So if you are trying to multiply, whoops, T-I-P-L-Y, with the same base but different exponents, you're going to add the exponents. So in this first one here, both of them have a base of m, but I'm going to add those different exponents. 3 plus 7 gives me 10, right? M to the 10th. Cool, very cool. What am I going to do for the next one? How many different bases am I going to end up with the second example? What do you guys think? How many different bases are right here? Are going to be in my final answer that I write on the line here. Here, we just had one base. Right now, there's 4 bases, right? But 2 of them match. So right now, we do have 4 bases, but 2 of them match, and then 2 of them match. So we'll end up with 2 different bases. Yeah, right. Good. So we'll have an A base and a B base. So then now we're just going to combine those exponents. So we're going to add the A exponents. So 12 plus 11, what would that give me? What do you guys
23.
think? 23. Very good. So this becomes a to the 23. What am I going to add for my b exponents? There's a 2 here, but there's nothing on that one. What am I adding?
Two and 0.
You think so? Totally good point. But b to the 0 power, what would that be? Anything to the 0 power is always what number? 1, yeah. So it can't be that one, unfortunately. So what's the next choice? Just go, one more.
1.
1, yeah. So we're adding 2 plus 1. So b to the 2 plus 1. So b to the 3rd. Cool. What about this last one here? We have, how many different bases am I going to end up with? What do you guys think? How many bases are there? Right now there's 3, but my final answer is going to end up with how many? 1. You're right. Very good. Very good. It's just going to be p, because that's your only base. And then what are the exponents that you're going to add there?
1, 8, and 3.
Right. 1, 8, and 3. 1 plus 3 gives me 4. 4 plus 8 gives me 12, right? Is that right? Yes. Yeah. P to the 12. Good. And then there's just a little note down here that you can't add or subtract numbers with different exponents, only multiply or divide. So the rules will only happen with multiplying and dividing with exponents. You cannot add or subtract them. They have to have the same exponents. Questions? Any questions? Neat, no questions. Okay. Okay, so what you guys think there? What would we end up with? You guys go ahead, think about it, write her down. Do you think we would end up with answer choice 1, choice 2, or choice 3? S to the 3rd times S to the 4th times T to the 7th. Oh, pardon my God. What do you guys think there? Ooh, we're doing great on time. I was worried. I was like, oh my gosh, it's probably 12:30. It's not. So giving the slight hint that don't forget our rule says that if the bases are the same and you're multiplying, you add those exponents. Emma says choice 3. That is Emma's opinion. What do you guys think? Ava, Cade, Bria, Nadia, Jaden, Addie, Evan, with the cool shiny Pokemon that I'm jealous of. What do you guys think? So we keep the base the same and just add those exponents. And what I see, oh, Evan says 3, beautiful. Nadia says 3, nice. Yeah, what I see there, I see that this T to the 7th, that's the only one that has a base of T. So that means you can't do anything else with it. So it definitely can't be T to the 14th. It's definitely going to be T to the 7th. And then we add the exponents, 3 plus 4, and that gives you 7. So you guys are right. It is 3. Yay, you're awesome. Very cool. Any questions on that? Any questions? Okay, so now we're going to talk the power to a power rule. And Marina, can you tell me, did this rule show up anywhere in the homework? It was in the notes, but I didn't really see it on the homework. I could be wrong. The raising a power to another power, did that show up? Freya, I can't remember, was that no to my question now or a previous question? Okay, well, we'll go through it just because it's pretty quick. Previous, okay, thanks. It's a pretty quick rule. We'll just write it down, why not? So, okay. So just in case, another exponent rule is raising a power to another power. So in this example, you have one base that's already being raised to a power, and then you're raising it to another power. And when that happens, you multiply the two powers. So x to the 6. So here I have one base. I'm going to multiply the two powers. Z to the 6 times 3 gives me 18. If you have a number and then a variable, you got to be careful that that exponent gets shared with everything in the problem. You got to distribute that exponent. So this turns into 2 to the 6th, x to the 6th. And then what is 2 to the 6th? It's the same as 2 times 2 times 2 times 2 times 2 times 2, x to the 6th. So what is that? 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2, 64. Is that right, guys? Is that right? Math in the brain and me usually don't work out too well. What do you guys think? Did I lose you all?
That's right.
That's right? Okay, good. Good. What about the rest of you guys? You still with me? Still alive? We're almost done, I promise. I know, it's a lot, and it's not the most exciting. Even though I think it is, it might not be to everybody else. Should I take a minute and just scream into the phone? No. I downloaded a scream button. What makes you sad? Screaming? That would make me sad. So, yes, I want you to be sad. No, I'm just kidding, I don't. Trust me, I could go on. See, look, I downloaded a screaming button that I can use for my kids when they're fighting. Did you guys hear that? Me too, Freya. You guys are awesome. Best class. Yeah, so I woke you up a little bit. Good. Okay, let's distribute this guy over here. So what exponent am I going to distribute to everything inside the parentheses here? What do you guys think? What exponent is going to get shared with everything in there? 3, right. So I'm going to go -5 to the 3rd. The numbers are separate from, that's a different base entirely. So a lot of people forget to carry it to the number as well. So don't forget about the numbers because they cry. They cry. Here's a number. This is a number 5. There's his eyeball. He just got one. He's crying. Don't forget about me. Poor numbers. Okay. So then the m to the 7th also gets shared with that exponent 3, and then the n to the 3rd. And negative 5 to the 3rd, we can evaluate that, right? That's negative 5 times negative 5 times negative 5. Negative 5 times negative 5 is 25 times negative 5. What's 25 times negative 5, guys? I'm not going to try and do that in my head. That would be a sad day. And this, what we're doing right now is we are evaluating negative 5 to the 3rd. So it's the same as 3 negative 5s being multiplied together. And that is 25 times negative 5. So what's 25 times negative 5? What do you guys think? I asked my cat and she's sleeping. She doesn't know. Silly cat. Yeah, I'm gonna do it, but if I get done before someone answers, then this live session will never end. Ever. I will see to that. No. What do you guys think? Typing it in. 25 times negative 5. What do you think? You did the first two, which is great. Nadia, you got it. Nadia saved everybody. Now we don't have to have a live session forever. Haha, no. Just kidding. But am I? No. Okay. So negative 125. Oh, that's okay. No, Marina, I thought you did the first part. That's what I was saying. You probably did. Yeah. So it's okay. No problem. So then the next one, m to the 7th, we're raising it to the 3rd. So the rule tells me just to multiply those exponents. So what's 7 times 3? What do you guys think? $21. Yes, yes. And then that n to the 3rd is just n to the 3rd. Cool. So power to a power rule, you multiply your exponents. And that's only if there's one base and that base is being raised to a second power. If there's two bases, then you got to add those exponents. So let me know if that's not clear, yeah, any questions with that. Okay, we got to talk dividing, and then we're done. Pretty cool. So when we're dividing with exponents here, the rule says if the bases are the same, you're going to subtract the exponents. And it's always the top minus the bottom. So in this one here, bases are the same. So I'm going to go top minus bottom. What am I going to put for that exponent? What do you guys think? Top minus bottom. 13 minus 2.
11.
11. Yeah, very good. So we would go 13 minus 2. Pardon me. And that is x to the 11th. Good. Now, if there's a number there, definitely divide the number first. So first we're going to go 42 divided by 6. What is that? What's 42 divided by 6? It's like we're kind of
7.
7. Yeah, it's like we're kind of slicing this guy in half a little bit. So the numbers we divide, but the bases with the exponent we subtract. What would I subtract here? What do you guys think? What is
7 minus 1.
Yes, very good. I would go 7x to the 7 minus 1 or 7x to the 6. Don't forget, if you just see an x down there, that means they have an exponent of 1. Good. Beautiful, my friends. All right. Okay, what do you guys think? So in this one, it's kind of cool because you can do it a few different ways. If you wanted to make yourself crazy, you could figure out 4 to the 25th and then divide it. If I were you, let's use that exponent rule first. So what would I get if I simplify that with the exponent rule? What would I subtract? Because the base is 4. What would my new exponent be, or what would I subtract here?
25 minus 22.
You got it. I would go 25 minus 22. So I end up with 4 to the third. And which one of these is 4 to the third? Freya, you got it. Good. Well, number 1 is what your exponent would be. But, and I'm so glad that this question exists because a lot of people get confused. If you see 4 to the third, that's different than x to the third. We can actually figure out what that is. And in algebra, if you can ever figure out what something is, you definitely should do it. So we would go 4 times 4 times 4. And what would we get? Oh, it's none of those choices, is it? Yeah, these are incorrect. Oh, wait, no. Jen's crazy. You're right. It is one of those choices. Okay. It is one of those choices, definitely. So what's 4 times 4 times another 4?
64.
64. Yeah, very good. You got it. Good job, Goyles. Number 2, 64. Questions. Is anybody like, what? Exponents? You crazy. Any confusion? Any of that? Let me know. But that is all I have for you, lovely people, today. Thank you for listening to me. No, you're not. You're awesome. You were answering correct. Go for ya. You were. Bye, Evan. Thank you for coming. Oh, Emma. I love that. And you're right, because it's not about being a genius at math or whatever. It's about learning and growing. Gotta get there. Oh, Emma, that was awesome. Good job, you guys. You guys are so awesome. I'm so lucky to be with you guys this year. Bye. Oh, you should. Yeah. I like that. We know.